Alright, it is like mechanism day. So we had a bunch of quizzes about mechanisms. We're going to have a bunch of answer keys about mechanisms. And this says write a mechanism for the reaction of 1-bromo propane with sodium iodide. And so as with all the other mechanisms, you want to be able to draw the structure. Propane would be 3 carbons in a row. And now we've got a bromine on the first carbon. So here's 1-bromo propane. And one of the things that I would notate here, this is a primary halide, alkyl halide, and that's set up for an SN2 type mechanism. So if we see a nucleophile, that's going to go after the bromide. When you look at the sodium iodide, the sodium's just pretty much a spectator in all our reactions. And we can draw that as separate or just next to the iodide. And iodide is a pretty decent nucleophile. Anions are typically bases and or nucleophiles. And the thing is, when you see a primary carbon, it's exposed to attack from a nucleophile, whereas this nucleophile, the iodide, is pretty good. It's going to come in here, attach to the carbon, and drive the bromine off. So if this is an SN2 reaction, which happens when you have a decent nucleophile attacking an exposed primary carbocation, or not carbocation, a primary carbon. So this iodide goes in, attacks this primary carbon, pushing off the leaving group, and then you end up with the iodo compound instead, plus sodium bromide. And this reaction can go forwards or backwards. So what'll make sure you get the product you want is if you overload it with 100 times as much sodium iodide as you have the 1-bromo propane, then the reaction will go forward 100 times as much as it'll go backwards if they were equivalent strength nucleophiles. In reality, the iodide's a little better, so you're going to get this guy. So SN2 reactions are one-step mechanisms where the nucleophile just pushes off the leaving group. And that's what usually happens when you have a primary bromide or iodide or chloride or some other leaving group. Now this second quiz question says the mechanism for the reaction of 2-bromo 2-methyl propane. So we can start with the propane, and now we're going to put a bromine on it and a methyl group. And this should be noticed that this is a tertiary carbon and a tertiary butyl group, 4 carbons and a T, that's tert-butyl bromide. And the tertiary substrates, there's not enough room back here for a nucleophile to go in and attack, but this can fall apart on its own to give the stable carbocation. So when you see the tertiary substrate with a leaving group on it, the leaving group just leaves in the first step, which gives us the tert-butyl carbocation and the bromide. And then just like the last one, if you have an abundance of sodium iodide there, the sodium iodide will get involved in the second step, where the iodide nucleophile will go and bond where the bromide was. So that'll give us our iodide product. So you end up with 2-iodo 2-methyl propane. And then you'll have the sodium spectator going with the bromide in your final reaction mixture. So 2 mechanisms, both substitutions. So we talked about SN1 versus SN2 substitution reactions. And those are if you have something that could be a leaving group and something that's a nucleophile, there will be a replacement reaction where the nucleophile replaces the leaving group, and it's just a matter of mechanism. whether it's exposed enough for the nucleophile to push the leaving group off, or whether it's stable enough to just have the leaving group leave on its own and create the intermediate that then the nucleophile can attack. So hopefully you got this cleared up in lecture. If not, this practice should help get you ready for the final. So right on.